December 8, 2020. The Optima Belle chemical facility in Belle, West Virginia. One employee was killed and 2 others were evaluated for respiratory irritation when a pressure vessel exploded, causing a fire and toxic chemical release.
Our report identifies several factors that led to this tragedy. In particular, we have found that gaps in existing regulations do not adequately protect against hazards presented by reactive chemicals. This long-standing safety gap must be addressed.
Optima Belle is a toll manufacturer, or a company contracted to provide chemical processing services, typically using its own equipment. On the day of the incident, Optima Belle was working on behalf of Clearon Corporation to conduct a batch tolling operation. The tolling operation involved Optima Belle dehydrating a chemical called CDB56. CDB56 is a white powder that is used as a source of chlorine for cleaning and sanitizing products. When CDB56 is exposed to high heat, it can decompose and release chlorine and other toxic substances. The batch operation was intended to dehydrate CDB56 to transform it into a different compound that Clearon calls CDB63. CDB63 is a white granular material that is used for water chlorination in swimming pools, as well as in detergents and bleaching agents. Like CDB56, it can also decompose and release toxic chlorine when heated. For the batch dehydration process, Optima Belle planned to use a type of pressure vessel called a rotary double cone dryer. Clearon, however, had never before used this particular kind of dryer for dehydrating CDB56. Therefore, Optima Belle developed a new procedure for the dehydration operation. Their plan was to heat the compound by applying steam to the jacket of the rotary double cone dryer, while the dryer rotated to tumble the contents inside. And equipment would be used to create vacuum conditions in the dryer to help remove any gases produced, such as water vapor. Optima Belle, however, did not realize that heating CDB56 inside the dryer could cause the compound to decompose. On the morning of December 8, 2020, Optima Belle employees started the first of 4 planned batch operations to dehydrate the CDB56. They applied heat to the dryer, and workers from both Optima Belle and Clearon monitored the progress. But by late afternoon, workers observed some operational problems. They stopped the dryer to troubleshoot. About an hour later, they restarted the dryer's rotation, and steam was reintroduced to the dryer's jacket. But problems persisted. A sample of material taken from the dryer around 7:30 p.m. showed that moisture levels of the compound were not decreasing as expected. And now the white material contained dark specks. After Optima Belle texted Clearon about the issue, workers stopped the flow of steam to the dryer's jacket and stopped the rotation of the dryer to investigate the cause. Both Optima Belle and Clearon workers suspected that the dark specks could have been due to corrosion of 2 stainless steel valves on the dryer, which was otherwise constructed of a corrosion-resistant material. Later, an Optima Belle employee told the CSB that when looking inside the dryer to investigate the suspected corrosion, the compound inside appeared lumpy with a yellowish tint and smelled like chlorine. While the workers were troubleshooting, the internal temperature of the dryer continued slowly increasing, even though no steam was flowing into the dryer's jacket. That is because, unknown to the workers, the earlier heating of the dryer had likely caused the compound inside to start decomposing, and a dangerous runaway chemical reaction was now underway. Workers continued troubleshooting, and by 9:30 p.m. Optima Belle and Clearon agreed to stop the batch operation for the night and continued to investigate the cause of the black specks the following day. But at approximately 9:40 p.m., the decomposition reaction underway in the dryer increased rapidly, causing the temperature and pressure inside the dryer to spike. Within minutes, the dryer catastrophically exploded. Metal debris from the explosion struck a nearby methanol pipe, causing it to rupture. The released methanol ignited, and a fire broke out. Other metal fragments from the dryer were found up to a half-mile from the site. One Optima Belle employee was killed. 2 others were evaluated for respiratory irritation, and 1 member of the public reported an injury related to the explosion. The CSB launched an investigation and found 5 safety issues contributed to the severity of the incident. They are process knowledge management, thermal hazard assessment, equipment selection and design, tolling of hazardous materials, and regulatory coverage of reactive hazards. The first safety issue is process knowledge management. As part of their tolling agreement, Clearon provided a technology package to assist Optima Belle in the development of the design and operating procedures for the dehydration process. But the CSB found that Clearon's technology package was inadequate and lacked critical known information on the decomposition of CDB56. For example, Clearon's own safety data sheet for CDB56, which was included in the package, listed its decomposition temperature as between 240 and 250 degrees Celsius. But the CSB found that in the 1970s and 80s, a Clearon predecessor had conducted testing that showed CDB56 could decompose at much lower temperatures. These findings were documented in a report that Clearon had in its possession, but did not provide to Optima Belle as part of the technology package. And post-incident testing of the material confirmed that CDB56 could begin a runaway decomposition at just 81 degrees Celsius. Because Optima Belle was not provided this crucial information, the company believed the dryer temperatures would be low enough to avoid a runaway decomposition reaction by design.
Accurate process and product knowledge is essential for the safe operation of chemical processes. There can be little expectation of safety if the companies operating a process don't fully understand the chemicals and their associated hazards. Our investigation found that Optima Belle lacked crucial information on the decomposition of CDB56. Accordingly, we found gaps in the ways that Clearon maintained and managed its key process knowledge, particularly in the way that it managed that knowledge with respect to its toller, Optima Belle.
As a result, the CSB made a recommendation to Clearon to develop and implement a comprehensive process knowledge management program, or evaluate and revise existing process safety management procedures to ensure consistency with industry guidance publications. And the agency recommended that Clearon update its CDB56 safety data sheet to more accurately represent the known hazards of the compound. The second safety issue involved in the incident is thermal hazard assessment. The CSB found that both Optima Belle and Clearon failed to effectively assess the hazards of CDB56 and the batch operation. For example, both companies failed to identify the temperature at which the material could decompose, failed to conduct adequate literature searches for public or internal safety data, and failed to use readily available reactive hazard screening methods to assess the reactivity of the material. Had Clearon or Optima Belle performed a thorough thermal hazard assessment, the parties could have understood the hazards of the dehydration operation, and the explosion could have been prevented.
There are many publicly available tools that companies can use to screen new or existing chemicals for reactivity hazards. Some of them are simple screening tools that can be used to quickly determine if further research is required. Others, like differential scanning or accelerating rate calorimetry, provide detailed, quantitative lab results that can be used to design a safe process. Using these thermal and reactive hazard assessment tools and developing processes accordingly can prevent tragic accidents like the Optima Belle explosion.
In its report, the CSB recommended that Optima Belle develop and implement a written thermal and reactive hazards evaluation and management program. The third safety issue that contributed to the incident at Optima Belle is equipment selection and process design. Optima Belle used existing production equipment for the batch tolling operation, but the CSB learned the equipment was not designed, sized, or re-engineered for the process. As a result, the dryer was unable to quickly cool the contents if they became overheated, nor was it able to relieve the pressure generated during a decomposition. And on the day of the incident, Clearon and Optima Belle essentially conducted an experiment on a new method to dehydrate CDB56 at full production scale. This was done without first experimenting at a laboratory or on a smaller scale, which could have alerted the company of hazards and led to changes in the process. Instead, the end result of this decision was a catastrophic explosion.
We found that Optima Belle's pressure relief system for the dryer was not designed or evaluated to relieve the pressure produced by the decomposition of CDB56. When using existing equipment for a new process, companies need to ensure that the equipment design is appropriate for the proposed new process. Had pilot or lab scale studies been conducted, Optima Belle and Clearon likely would have gained additional data on CDB56 and improved process knowledge. This might have led to changes in the equipment or process design, potentially preventing the explosion.
The fourth safety issue found by the CSB is the tolling of hazardous materials. Companies often augment in-house production by outsourcing chemical processes and other operations. These agreements are called tolling contracts. Clearon established a tolling contract with Richmond Chemical, a tolling broker, who in turn contracted with Optima Belle. The Center for Chemical Process Safety, an industry organization, provides guidance for safe and effective tolling arrangements. But the CSB found that neither Clearon nor Optima Belle adequately followed that guidance. Their deficiencies included inadequate exchange of process knowledge between the tolling parties, inadequate mutual involvement in the process hazard analysis, inadequate understanding, characterization, and analysis of the hazards of CDB56 and the dehydration operation, and no evaluation of the technology change from the type of dryer typically used for the process to the rotary dryer available at Optima Belle.
Outsourcing the production of a hazardous material does not outsource the responsibility for process safety. Effective process safety and the prevention of a catastrophic incident are responsibilities that should be shared by all parties involved in a tolling operation.
As a result, the CSB recommended that both Optima Belle and Clearon develop and implement a written program for tolling process design and equipment selection using available industry guidance. Finally, the fifth safety issue that contributed to the incident at Optima Belle is regulatory coverage of reactive hazards. CDB56 is a reactive chemical that can undergo a self-accelerating decomposition when heated. At Optima Belle, the decomposition led to a catastrophic explosion, fire, toxic emissions, and the death of an employee. Yet this chemical, and many such reactive chemicals, are not regulated under OSHA's Process Safety Management Standard or the EPA's Risk Management Program rule. Had CDB56 been covered under those regulations, Optima Belle would have been required to implement risk mitigation and management systems that could have prevented this incident.
The CSB has a long history of investigating reactive chemical incidents, including producing a 2002 study in which the CSB called on OSHA and the EPA to expand their standards to address reactive chemicals and their hazards. To date, however, neither agency has acted on our recommendations.
Therefore, in its final report, the CSB reissued its 2002 recommendation to OSHA to amend the Process Safety Management Standard to achieve more comprehensive control of reactive hazards that could have catastrophic consequences. And the agency reiterated its 2002 recommendation to the EPA to revise the accidental release prevention requirements to explicitly cover catastrophic reactive hazards that have the potential to seriously impact the public, including those resulting from self-reactive chemicals and combinations of chemicals and process-specific conditions.
The CSB believes OSHA and the EPA must strengthen their regulations on reactive chemicals. Regulations addressing reactive hazards will help keep similar incidents from occurring, prevent injuries, deaths, and protect those who live in nearby communities. The time is now for those agencies to act. Thank you for watching this CSB safety video.
For more information, please visit csb.gov.